The whole point in section 4.3 is to make connections between the graph f and the behavior of the derivative f prime, and now even the behavior of the second derivative f double prime. Before we can get there, we have to remember what a critical point is. Critical point is a point, an x value, on a function f, at which the derivative of f is 0, or at which the derivative of f is undefined. And remember that the whole reason we started looking for critical points is because we wanted to find out where functions had relative extreme values. So notice that here's an example of a function that has a relative maximum up there. And you can see that it happens on the graph at the place where the tangent line to the curve is horizontal. Here's another place where I have a relative maximum. It happens at a place where the derivative is 0. At a place where the derivative is undefined. Again, I have a relative minimum here, and it's at a place where the tangent line is horizontal. And then this one more guy. Here's another place where I have a relative minimum. It's at a place where the derivative is undefined. I have a corner. So take a look at this for a second. This is possibly the most common kind of question on the AP test. You're going to be given a function, and you're going to be asked to find if this function has a relative minimum or a relative maximum, and where. So we can start by finding the critical points, but just finding the critical point doesn't clarify for us whether the function has a relative minimum, the bottom of a valley, or a relative maximum. So here's what we have to start to look for. Notice that this function has a relative maximum up here, and it happens when the derivative finishes being positive, where the function finishes going uphill, and the derivative starts to be negative. That means the function comes back downhill. So using this information, it's very important. This gets a big important name. I'm going to move to the next slide. All right, we have the first derivative test for local extrema, and I want to clarify, this is not the first of many tests. This is a test using the first derivative. So if a function has a relative maximum, that means the function must have come uphill toward that maximum and now comes downhill away from that. If we use the first derivative, the language of the first derivative, we can say if f prime changes from positive to negative, that means if f was increasing and now starts decreasing, then f of x has a relative maximum at x equals c. C has to be some critical point, a place where we know the derivative is 0 or the derivative is undefined. So similarly, we know we're going to come down into the bottom of a valley if f decreased into the valley and then increases back up. In terms of the first derivative, that means the first derivative had to have been negative so that the function goes downhill, and then the first derivative becomes positive. So if a function f prime of x changes sign from negative to positive at c, then f must have a relative minimum value at that critical point. So sometimes, I'm step 3 now, sometimes a function has a critical point, so maybe there's a horizontal tangent, but it doesn't actually reach a peak or hit the bottom of a valley. So if f prime does not actually change sign, maybe it was increasing and then slows down but then starts increasing again, it doesn't mean we got to a relative extreme value. So if f prime does not change sign at a critical point, then there is no extreme value at that critical point. So let's start this example. We'll get cut off and we'll have to continue in the next video. So this says use the first derivative test to find the relative extrema of this function y equals x cubed minus 12x minus 5. Well, I'm going to use the first derivative test. That means I need the first derivative. So y prime is 3x squared minus 12. My very first step is to figure out where y prime is 0 so that I can start to figure out where y prime changes sign. So I'm going to set y prime to 0. I'm going to solve by factoring out the 3 and factoring.